that I can, there. Now here comes my desktop. I don't think you want to see my zoom. The first thing I want to do is make available to you a little program. I should say a PFD file of everything I'm going to do today. It's about 37 pages long, but it's going to cover everything that I do with screenshots, so you can see all the menus that I go through and everything that we do here today. So I can do that, if I understand right, by activating my chat screen. As soon as I find it. There it is. Okay, and going over here to File. Pardon my slowness. I'm looking for it, and my video didn't update. The camera is hiding half of it. So let me cancel this and reopen it now that I've moved it. And I'll be darned, it puts it back in the same spot. Okay, well, we'll get to that a little bit later then, but I will have a PDF download that's available so you can follow all this keystroke by keystroke. The first 6 pages of this I'm going to go through real quick because they just covered the hardware, and the hardware is actually my own. I designed it, and this is a prototype card. I did this whole thing for about 25 bucks. So Clarence wants to come in the group, let him in. So let me skip on down through here. This is a basic overview of the whole circuit design, so I won't bore you to death with that. We'll move on down here. This is where I let power come into the board, right? And you can either bring in 18 volts AC and I rectify it, put it to a 12-volt regulator, and then take that 12 volts out to use for the Tortoise cards. Then I also feed it into a 5-volt regulator to run all my logic on the card. Like I said, I'm going to run through this quick because this is not a real great value for today's lesson. Then RS-485 is how I communicate back to JMRI. Now, this is something you need to know a little bit about. What I'm using is Chuck, oh, can't even get his last name out right now, but it'll come to me in a minute. But I'm using CMRI, Computer Model Railroad Interface, which has been around since the 80s. And it talks RS-485, and JMRI is all set up to be directly interfaced to CMRI. So it makes it real simple. I designed a card to use that interface, and it works great with JMRI. The secret to know about using RS-485 is that the first card has to have the resistors, and then you cut the resistors out of whatever the second and third card if you add them to it. This is the Tortoise Control part. This you'll find a little interesting. Here on the left-hand side, the nano chip outputs feed in on these 2 wires right here. Let me see if I can get my illustrator up. Okay, yeah, that's better.
What chip are you using there?
I'm using a Nano.
Oh, it's an Arduino Nano?
Yeah, an Arduino Nano.
Okay.
Okay, I'll show a picture of it here in a minute. Okay, but the 2 outputs from the Arduino come in right here, and they're pulsed. See, and this chip remembers which wire got the pulse to control the Tortoise motor. And so the outputs of this chip come along here to the output terminals. You can think of that as the Tortoise motor. And it latches in and remembers the state. That's why I can pulse the input here. And by pulsing it, I release the wire. And that's important because if you follow these wires down to a terminal strip on the board, I call it Tortoise Control. And this is ground coming out right here. You take it out to your switch, and then you either throw the switch left or right, and it comes back in on the selected wire. And that will put the pulse onto the 485 chip, and it will remember your manual pulse. So you can have a local control switch. It's a momentary contact switch. That way it releases control when it's not in use. Now, I can't use that annotator because I can't switch pages.
So you've got a toggle push button that goes, and if you push it button, the Tortoise goes one way. If you push it again, it goes the other way?
That's correct.
Okay.
Okay.
So Jim, it's a toggle?
Yes,
or a push button?
it's a momentary toggle switch.
Okay.
It has to be a single pole double throw.
Okay.
Okay. And I prefer that over a push button because then I'm short. And when I stand up next to so many of these layouts, I can't see back into the yard to see those switches where they're at. You know, so by using this arrangement, I can have the switch label thrown or closed. And by looking at the switch, I can validate where I'm putting it. And I think that's, for me, that's a much better way to do it. And good, now I got control of my screen back. I put an output on the card where you can use the ground so that you can feed your signals directly from this card. You're not running it from another source. This is the meat and potatoes of it, guys, right here. Coming out of the Arduino, I have all the feed-in wires here on the left-hand side, and I put opto isolator card chips in here. The reason I do that is the left-hand side, these resistors over here, this is a 5-volt circuit. But on the output side, this is a 12-volt circuit. So I don't want the two bleeding together. So I use an opto isolator to keep the circuits apart. Feeding out, I have 11 outputs over here. These are the ones that I'm going to use for the signals. I built in the dropping resistors so that you don't have to solder in or play around, just use your LEDs directly to the board. If you want to get cheap, you can leave these diodes out. I only put those diodes in. Those are protective diodes in the event that you hook things up backwards. If you put the positive side there instead of the negative side, you're not going to burn anything up. That's the only reason they're there. So if you wanted to go cheap, you could just put a little jumper wire in there and get even cheaper on this. This becomes an important part of our lesson, guys. Now, I'm not going to teach you about signaling today, but I'm using signals as the example because they're a nice, pretty feedback, okay? And that also, that's what the card was designed to do. So here you can see that I'm using a double-headed signal, right? 3/2. And I've got them labeled here to output 1, 2, 3, 4, and 5, and I've assigned a color to them. And these are the outputs that I'm going to be talking about as we connect this card back to JMRI, okay? So I've got a 3/2 head, and then here, this is my first mistake, guys, okay? This is a 3/1 head. This should be a 1/3 head. I grabbed the wrong signal head for my demonstration, right? But just remember, flip that signal upside down and it'll make sense. And then of course, we got our little dwarf signal, okay? Mine's going to be a yellow over red, or green over red, my mistake. Okay. Now, on the card, these represent all your LEDs and your signals. They're common cathode. That means the negative side is typed common. Okay. And we're going to control the positive side off the card. On the card, I also have 3 inputs. And the reason I do this is that since this is controlling a sighting, I want to know the status of my turnout. So I use input 1 to say my turnout is set to closed, and input 2 is used to show that it's diverging or thrown. And then input 3 I use as my block detection, so I can tell if anything's sitting over that switch. This is the example of what we're going to be using today. This represents the sighting entrance. So you see here on the left, I have a 3/2 head. Okay. On the far right, I have a 1/3 head. Again, that was my mistake. I drew it all upside down. And then on the sighting is the dwarf. Okay. So, and I label these A, B, C. Drag that over. You can see I got A, B, C. In the PDF file, I'll use those terminologies so that you can come back and know which switch I'm talking about. Okay, Kelly Russell's joining us. Good morning, Kelly. All right. Now we're into the actual meat of the lesson. Before we do that, I've got one other quick little shot I want to show you here. This is my desktop. This is, okay. It's too much for me to be able to move the camera around and keep it focused with my shaky, trembling hands. So I just took a picture of it. And here you can see, this is my little signal mock-up here. And we're gonna watch that light up and everything as we work. Here you can see my power supply is coming in right here. So I'm feeding 12 volts into it as a power source. My RS-485 connection is right here. Okay, a little hard to see, but it's the little yellow wires. Here's the little USB adapter. There's a spare one laying down here. It has a 485 chip in it, and it's got the USB end that plugs in. This little green dot on the far end here. Let's see if I can zoom in a little bit on that. Yeah, that little green dot right there, that's where you attach your two wires, okay? And over here on my USB hub, you can see the same little green dot and a yellow and white wire coming down here and plugging it in. So getting your communications hooked up is real simple. This little adapter, I bought 6 of them for $7, okay, from China. So they're cheap, okay? And so your interface is nothing. It just plug that in. JMRI recognizes it right away. Here's the little nano chip sitting right here. Okay, and what I do is I get the CMRI commands in there, and then I use a little bit of logic and I convert it over so that the nano understands what it's got, and then I feed it out and control the outputs here. Down here, this is where my Tortoise control switch is wired in, okay, where I can manually control my Tortoise motor. This is the output to my Tortoise motor. The red and black wires coming over here to my Tortoise. You'll see it move, okay? Here are the 13 outputs, the 11 outputs for my signals, my built-in LED dropping resistors, and my protective diodes, okay? Then up here, these are my 3 inputs, okay? Two of them coming back from the Tortoise motor to give me status, and the third one is hanging open because I don't have block detection. But I do have a jumper wire there that I'll drop it in so you can see it work. Okay. There's the nano chip. Okay, down here, the receive and transmit LEDs. I'll try to move my camera a little bit later here and let you see they twinkle like little stars because they're receiving and transmitting data. Here's the mock-up. This is what you're actually going to see, right? It's 3/2 and 3/1 and the dwarf. And again, this is my mistake. This next slide, this is what you're actually supposed to see, okay? So just remember that this one's flipped upside down. Now, why is all that important? Because of this. In the United States, almost everybody's using speed control signals, right? And so the placement on the mast tells you the speed, okay? So high on the mast is high speed. Middle on the mast is medium speed, and the bottom of the mast is your slow speed commands. Now, on most railroads, this is more money than I want to spend, so you seldom see a three-headed mast like this. But if it's not there, it's understood. It's a you understood. So if you only see it high on the mast, it's you understood that these two are gone. This slow is often replaced with the dwarf. The dwarf is always slow speed commands. It's never anything but a slow speed command, okay? So if I get as I go through here and turn lights on, you'll hear me using determination terms, medium clear or high clear, things like that, and you'll know the relationship of the heads. So that's why it's important to understand why I turned it upside down. Let's close that down and get it out of our way. And pretty much ready to start off here now. I'm going to open up Panel Pro, okay? You can do the same thing through Decoder Pro, but my preference is to use Panel Pro. Let me get myself caught up on my pages over here. All right, starting Panel Pro. Now here, you can have several configurations, and if you leave it alone in 10 seconds, it'll automatically start. My configuration was compatible card. Okay, so JMRI starting up. Up here in the far top left-hand corner is a simulator. Okay, I let that simulator on because I wanted you to see that I'm using more than one connection to JMRI. So let's see how that appears. Here on Panel Pro, if you look, you'll see I have a LocoNet connection. It says I'm using LocoNet simulator. Can everybody see that? Okay, and then just below that, it says I got a CMRI using serial COM port 14. So I have two connections. So let's take a look at how I did all that. We're going to go in here to Preferences. Sounds like we got a little bit of hum coming in from somebody. Okay, so here in Preferences, very top of the list, it says Connections. Okay, so the first one up is my LocoNet connection, and that's a Digitrax device, and I've hooked it up to a LocoNet simulator. We're not going to do anything with that today. I just wanted you to be able to see that you do have more than one connection capability. But if you look at the next tab, you see CMRI. Right? So to use this hardware configuration, you have to go into Connections and you click the plus button, and it says select what you want to do. So over here, I pull down, and there's a drop-down list of all the type of hardware that JMRI will accept. Okay, and I selected CMRI. And once I did that, it said, okay, that's a serial interface. So what port is that on? And here on COM port 14, okay. Now you notice I had 2 COM ports there. COM port 5 is used by my computer for another interface that I don't need to explain to you. But if you select the wrong one, you're going to get some red blob text up there that says, hey, I can't connect. Just go down and select the next one until you find the right COM port. That's the simplest way to do it. Okay, so that's how you would create a new one. I've already done that, of course, and set mine all up on COM port 14. So that's the very first thing you have to do. You have to go in here and you have to configure it so you can talk to a JMRI device. If you'll give me just a minute, I got to get rid of these pictures. They keep interfering. All right. Some of you experienced users out there, I want to get rid of all these little pop-ups on my screen. How do I do that?
Oh, okay. Why didn't you say that? You said,
Jim, try
Yes.
minimizing Zoom.
all you do is touch it and then.
Try minimizing Zoom.
Yeah, if you minimize Zoom, it should take it off your desktop. It'll just take it to the bottom, and that should get rid of us.
I've already minimized Zoom.
Oh.
Well, Jim, that worked here on my computer.
Yeah, well, I'll just have to live with it for this one. Next time I know. Okay, that's a
Well, they're
lesson
all
learned. So I want to get rid of my preference screen. Okay, of course it's going to remind you have to save it. Once you set this up, it's going to tell you you have to restart Panel Pro, because it only looks at these configurations when Panel Pro is starting up. So here I'm going to tell it, no, I don't want to save it because I already have mine configured. But once you restart, then yours would look just like mine here now. It would say LocalNet or whatever version of DCC you're using, and CMRI using COM port, whatever COM port you assigned it to. Now, what I'm going to do next, I've saved all this, so it's just a matter of showing you what I've done, okay? I'm going to go into Panels, Open Panels, and I have saved a panel, which is a screen type information, okay, in the compatibility card. So I'm going to open that. You notice I have a lot of different panels here, and I've saved them, and I can open up whichever one I want to use at this time. So you may have one panel set up for when you're playing with your trains by yourself, and you may have one for when you're doing ops day, different things like that. So you can have different configurations. Okay, so now that I've opened those panels, nothing seems to have happened. Okay, but down on my little card, I've got my little twinkling lights because I've told it to talk to my nano chip now. Okay, so now that I'm talking to it, I can look and see what it's doing. Let me catch up with my pages over here. I want to make sure that I'm not skipping anything. Yeah, I am skipping something. Now that we've got that JMRI driver installed and it knows it's looking for one, we have to tell it what we're going to use. So I'm going to go up here. You see now I have 2 connections on my menu up here. I have a LocalNet, which I can open, and these are all the things I could do on my LocalNet. right? I can configure cards, change my PR3 mode settings and do all that stuff, okay? Now over here on CMRI, well, it's a smaller list. I still have things I can do. The first thing I have to do is configure a card. It's called configuring a node, okay? I already have a node configured. So you can see here, it starts at address 0, okay? And there's several kinds of cards. I selected a CME card. So we'll go down here to add a node just so you see how this is done. These screens are a little bit confusing. Somebody's got their mic on. Please mute your mic there. Node address. You're going to go in here. It starts at node address 0. So I've already used node address 0, so I would put a 1 in here. Node type, there's 3 kinds of CMRI cards. CME is the most popular. It's an input-output mix card. So I select that, okay? I can put a delay on the receive, which unless you got real bad communications, you'll never need.
Jim,
Yes, sir.
Jim, so you're using the CMRI terminology, even though you've built your own system with an Arduino, is that correct?
That's correct. In the Arduino, I'm using a CMRI.
Sketch?
Say that again.
A CMRI sketch program that you downloaded to the Arduino?
That's correct.
Okay.
Okay. And so
Did you develop that yourself?
no, sir. That's ready-made and ready to download.
Okay. Okay.
Okay. And so is the RS485. That's a module that you download and just, say import when you're doing your coding. All that code is at the very end. We can go over that at the very end of, for the people that want to hang around and see that.
So what you've done is just so I understand, is you've taken a downloadable program that you found for the Arduino. Using the Arduino, you built your card that you could expand the outputs of the Arduinos to put in the opto isolators, the diodes, all of that stuff, so that you could drive the LEDs and the Tortoise. Is that right?
That's correct.
And now you're explaining how you're connecting it into JMRI.
Correct.
Okay, thank you.
Okay. All of this little matrix down here, you can ignore. That's if you're going to use special signaling and stuff beyond the scope of what we need to know for today. Just know that most of the time you leave that alone. It even tells you down here, leave it alone. Okay. And then you would add that node. Okay. Once you add that node, it'll be placed into the node listing like this, and it will tell you, the address of that node, the type of card it is, how many bits are on that card. Okay. There's 3 cards. That sounds weird, but the way JMRI cards are built, it's old technology. It's 8-bit technology. So it actually has 3 8-bit inputs, 3 sets of 8-bit inputs. So they refer to them as cards. So basically what you've got is you've got 24 inputs, right? Outputs 6. And again, that's based on the number of bits that are available. Okay, input bits 24, output bits 48. So 6 times 8 is 48. Okay, so that's how you would configure your card. Now that you've got a card configured, JMRI can talk to it. So we'll go out now and get into the meat and potatoes of this. But I want you to know this is basically the same procedure you go through if you're using a Digitrax card or, like me, building your own, or if you're using a CMRI card. this is still the same basic procedure. You have to go in, you have to set up your COM port, you have to set up the card type, then you have to configure your node. It's just each manufacturer does their own little windows and setups a little bit differently. CMRI is really a simple setup. Let me close that up and get it out of the way. All right, now we're going to actually get into hooking up some inputs. First thing we want to do, the simplest, is set up our sensors, which are inputs. We use those just to see if we've closed a switch, to open a switch, something of that nature. Okay, so you saw me go into panels, and I opened the panel. I selected the panel that I wanted, compatibility card panel. Okay, I'm going to close that. So now I'm going to go under tools, and I'm going to go to tables. Now, if you worked with databases, the word tables has a meaning to you. Okay, if you've been in an Excel spreadsheet, you might use the term sheet. Okay, and it just shows you how your data is split up into different areas. Okay, so I'm going to go into tables, and I'm going to select my sensor table. It'll be up in a second, guys. There we go. Sure wish I could get rid of those little screens. Okay, now here you see I've already set mine up. So you got to give it a system name, and you got to give it a username. The system name is what's used internally by the logic. Okay, the username can also be used, but it's for us humans. So we can give it nice English terminology, things that we might recognize. So I've labeled mine North Passing Tortoise Motor Mainline. Okay, North Passing Tortoise Diverging. So those are the two sensors that I'm going to look at to determine which way my tortoise motor is turned. Okay, and then I'm going to have North Passing OS, on station detection. So I'm gonna protect that turnout to make sure nothing is sitting on it. Okay, and so I have those three inputs defined. And how did I do that? I went down here to add. It comes up blank. Okay, and so add a hardware address. So I put a C for CMRI, and I did an S for sensor. Now, if I try to use address 1, 2, or 3, it's going to come back and tell me, hey, you can't use it. It's already busy. So I'm going to put 4, sensor 4. And then I'm going to type in a username. Okay, and for here, I'm just going to type in my name. You can type in anything there, guys, something that's meaningful to you to help you identify what you're working on. Okay, then I'm going to say create. And you can see it dropped it down there on the bottom. ISCS4, my name. It's in an unknown state. That's typically what they'll come up on, because the logic has never been activated to look at this yet. Okay, this clock running one, let me get rid of that one. I'll show you how to do that. This is an internal sensor used by JMRI, and it's used for its own clock. But I don't want to see it. It's in my way. So if you look up here, I've got the tabs. So I might have sensors in LocalNet, and I can filter out to just look at the sensors in LocalNet. I have none, okay? Or I can filter it to look just at my CMRI sensors, or I can filter it to look at my internal sensors. Okay, so I'm going to filter it to just look at my CMRI. So it's that simple, guys, to create these sensors, right? You just hit your add, right? Here you have to make sure you got your system connection. I forgot to show you that, set to the right device, right? So set it to CMRI and then put in the address, internal address. It doesn't, not, see over here, I got the little red over here. It's telling me must be an integer. So it didn't like what I was doing. CS4, okay. And it gave me a little green light. It likes that address. And then I put my username and I hit create. Unable to convert, all right, because it's already been used. Okay. And that's because I put it over here. Last time I put it in the wrong group. Okay. So I'll just delete that one. Come back to CMRI where I should have been. And now I'll say create, well, invalid address. I don't know why it wants to be picky on me now. Okay, guys, I don't know why that happened on me right now. But that's the process to go through to create your sensors. It's that simple. So now that we have some sensors, let's close them up. And we'll go back here to tools, tables, and we're going to go down here to turnouts. Whoops, up here to turnouts. I got ahead of myself on that one, guys. We're going to close that one back up. I wanted to go to signal heads first. Tables, signal heads. Close that down and pull it back up. Good, that cleared out my problem. All right, and what I'm going to do here, each one of those heads has 3 lights on it. Remember back in the PDF, I was showing you that we had a red, yellow, and green light for each one. And we need to understand which one is which when we hook them up to the board. So what I've done is I'm using the A, the B, and the C. Let me expand this down so we can see them all. Okay. Head arrangement so that you can understand in the relationship to where they were on the drawing. So the top head on the north passing side, okay, is defined, and how I did that. So down here on the add, I've got to always lower these and then bring them back up, guys, because they're getting hidden on me. There we go. And what we do here to add a signal head is you have to go first to this drop down and you have to say what kind of head this is. Okay, is this going to be a single output head? Is this going to be, in our case, we want it to be a triple head, triple output head. Okay, red, green, blue. Okay. So now I'm going to give it a system name. And I would put in here C, and I'm putting in the C again just so I understand mentally that this is a CMRI output. Okay, you can put any letter there you want. However, the H is mandatory for the system, so it knows it's a head. So this is a CMRI head. Okay, and I've discovered that it only wants capital letters there. So just to let you know, if you put it in lowercase, it'll pop back and refuse it. So you need capital letters there. So I put in CH1, okay? And then I typed in my, my name, okay, North Siding. Then down here, you get a choice, right? For your green, well, this one's blue. So I've selected the wrong one. Let me cancel that. Let me go back here and add triple output. There, green, yellow, and red output. I see I selected the wrong type output. So it kept the system name, it kept the username. Now down here for my green output, I could have already defined an output for that, but I haven't yet. So I'm going to tell it I'm going to create a new one. Okay. Now, where am I going to create that output? Am I going to create it on my local net connection or on my CMRI connection or internally? So down here, I create it. I'm trying to catch up with myself here, guys. Okay. So I'm going to create it as a CH1. And it tells me I've already used that address. So I'm CH 99. I've already used all those addresses, so. I don't know why it wants to. CH5, CH6. All right, guys. I don't know why it's not taking my usernames here. But let's continue on. We understand there's an error there. And maybe I can come back and pick that up again. I don't know why it's not taking it. Okay, and I would do the same here, create a new one for my red. So my green, yellow, and red, I create. And that gives me then a new entry in my table, CH1, and it gives me different appearances. Remember, a head can only give you an appearance, okay, on a signal. So I've got it in dark, I can put it in red, I can put it in yellow, I can put it in green, flashing red. So let me see if I can get that second camera up. Wrong screen. There we go. Now I've got everything in dark, but I'm gonna put the top head on the 3/2. I'm gonna put it to red. Okay. Now I'm gonna put it to yellow. And now I'm gonna put it to green. Okay. And I can even make it flashing. Let's flash to green. And see how nice JMRI is for you? It knows how to do all that logic for you automatically for your signals. It makes it real convenient for starting up your signaling. Okay, so I go through that same procedure then for every one of these. I create, according, so the bottom head, we'll look at this one. Let me actually just pull up the edit feature once I clean my screen. Go into edit so you can see the actual. Sorry, I have to do that up and down, but it pops up under those little videos of you guys and it hides it from me. All right, so you see here, the bottom head on that signal is only 2 outputs. So I selected a double output, okay? I gave it a username, a bottom head, okay? Now it's showing use existing, but I actually created it as a new. Okay, and because I've created other ones, I could pick from the list now if I needed to, right? But I select the right address for that green output. I select the right address for the red output. Okay, I'm gonna cancel that. So I just do that all the way down through here. And B is my top head and my bottom head, right? So I've got I'm showing a 3/2, but actually it's a 1/3, if you forgive my mistake there. So I configured that one. And then the last one here is my little dwarf signal, okay? My yellow, my green over red, okay, signal. So once I've created all those heads, let me put that down out of the way. Then the next thing I'm going to do is go back into Tools, Tables, Signals, and the signal mast. Okay, now what's the difference between a signal head and a signal mast? The signal head, a mast is a complete unit, everything that's on the pole, let's put it that way. So a mast may have just one head, may have 2 heads, it may have 3 heads. So what we're going to do now is we're going to combine all those individual heads on that pole and create a mast. That way in logic, we can talk in aspects and not talk about red, green, yellow, or head 1 or head 2. We just talk about the signal aspect that's being shown, which is the information we're trying to convey to the engineer. That's better. Okay, so I've already created my 3, but the way you do that, you come down here to add, you give it a username. Now here you have to select a signal type, a signal system. There are several built in to JMRI. So if you're modeling a particular railroad, your signals may already be defined for you in here. Your signal aspects may already be defined for you, okay? Now in my PDF, I expand on this a little bit more and I show you more pictures. Let me do that. Let me just drop down here for a second and open up that PDF. I think that's worth taking a minute to look at. So pardon me scrolling by here real fast to get down into the manual. Okay, here's where I want to start. Blow that up a little bit for you. You go to the JMRI site and you'll be introduced to signal mast logic. And it explains to you a lot more about what we're talking about here. We don't need to go into that detail here because I'm just using them as a demonstration, not a real signaling system. But I'm going to be using CSX 1998 as my signal system. for this example. So if you select your signaling system, then you can go into JMRI and it defines for you in the documents all your signal aspects for that signal system based on their table. So here you can see I'm using for clear, see if I can blow that up a little bit more. Yeah. See here under Rule 281, a clear indication is a green over red. Okay, so that's an aspect, right? A limited approach is red over yellow that's flashing. That's why the flashing is important. Okay, and then advanced approach. So it does everything that's built into JMRI for this signaling system. So that's real nice. Now, I know a lot of this is beyond what most of us want for signaling, and I can appreciate that. So JMRI has what they call the model railroad signals, which is basically, let's follow the turnouts. Let's have the signal show the status of the turnouts. So it simplifies it even more for you if you want to use a simple one. So let's see if we can add a signal mast. All right, let's try it again. Guys, I think I've overloaded my little XP computer here. Let me go back and see if I can reopen that. There we go. So I give it a username, and in my examples, you can see I'm following through here with the north passing sighting facing, north passing sighting dwarf, north passing sighting trailing. So those tell me where on that turnout my signal is placed. I had to drop it down. I covered it up. So then I select what signal system I'm going to use. Okay, so I scroll down through here. I lost the one that I used, but I select one. Okay, any signals system that you want to use. Mast type would be a block signal. Okay. Waiting room, who's trying to get in there? Okay, somebody coming in real late or joining back. Okay. So you select the signal. Double searchlight, triple searchlight, whatever you're going to use from that signal system. Okay. Then again, you tell it what connection is it going to be on. That one only wants to go to, I don't know why I can't find my signal system up in there. Sometimes they do an upgrade on you and then you lose things. But you can see what I'm doing is I'm going through here and I'm selecting my signal type. And then I'm going to select my mast. Right, then I'm going to put it on whatever system it's on. It says I may have lost my, no, it says I'm still got a good connection there. I thought maybe I'd lost my COM connection to JMRI, right? Because it's not showing up here. See, it's only showing up as local net, but it should show up JMRI, CMRI as well. Then down here, you get your different aspects that system allows you. And then you can say, I want to use this aspect, which is clear. I want to use the clear aspect, but I don't want to use the approach limited. So I could come down here to disable that one. So I can make my signaling system as thorough and prototypical as possible, or I can say that it's far too much signaling for me, and I can dummy it down, make the signaling system simpler. So then I would create it, and it would end up in the table here. So let me open the edit so you can see how I did. Okay, guys, come on. So you can see here on the top, I gave it a username, North Passing Facing, CSX 1998. That's the one I couldn't find in the list, guys. I don't know why it disappeared on me. Okay, and the mast type then I selected was a double head 3.2 color light, which matches what I've got on my mast out there. Okay, the mast driver was output matrix, which then gives you everything you see here on the screen. Then I assigned my outputs, okay, from the head. Okay, the same addresses that I used in the head. So CT1, CT2, CT3 became my top head. Output 4 and 5 became my lower head. Why, I wish I'd turn those little windows off first. And then down here, this is a little different than you would expect. Okay, for my clear head, see, I've checked these 3 boxes here. These are the outputs, 1, 2, 3, 4, and 5. And you check the ones that you don't want to be on, okay? So this is the green of the top head, and this is the red in the bottom head, right? So I have a green over red. So that's basically how you set up your signal mast. So now let's see if we can look at these. Okay, let me get my second little camera back up. Come on. All right, I left him flashing. I need to turn him off. The reason I have to go back and turn this guy off is that there's no logic behind these. This is just me telling it manually what I want it to do. Okay, so I have to go back and turn that bad boy off. Okay, so now all my signal masts are off. Oh, I'm not seeing my little signal mast. Let's just go back here and reopen it. Signal mast. Shorten this little box up. Keep it out from underneath. Okay. Now, move it over here. We're going to talk to the north passing sighting facing. So that's the 3/2. And I'm going to give it a clear aspect. Now, notice that I've changed my terminology. I'm not talking about heads. I'm not talking about color. I'm talking about aspects, the information that we want to transmit to the engineer. So I'm going to tell the engineer that he's clear. Come on, clear, light up. Whoops. Now let's try him. There you have a green over red. So you have a clear. So this is a high-speed clear because that's the high signal is green, right? And so that, all that is defined for the engineer in his rule book. So he knows his track speed, okay? And that's given to him in his rule book. So he's allowed to go as fast as what the rule book tells him he can do on that rail, okay? So now we can change that aspect and we can give him an approach. So now he knows he's approaching a red signal. The next signal he sees is going to be a red signal, right? So you got a yellow over red. So he's going to start slowing down in anticipation of that red signal. Now I'm going to change it to a medium approach. Now the red signal is on the top and the yellow is on the bottom. So I've changed my speed, right? So I've dropped out of the high speed and I've dropped down into the medium speed. And while we tell you that this is a speed signal, it also gives you a little bit of information about the direction you're about to travel. So usually you would see this medium approach if you're about to go into a turnout that's been diverted. So you're going to change your route as well as your speed here. When I was watching a video on signals from a man in Canada, he had an expression that really helped me understand this. And what he said was, if a signal ain't all red, it ain't red at all. Okay, and at first that didn't make a lot of sense. But what it means is, if a signal is showing red, but there's another head with another color, all the red is a placeholder, and it means ignore this signal. Okay, so that's why this red over yellow, I know it's a medium speed because it's on the medium head and it's yellow in color. Okay, so that's how I understand that. So now I'm going to change that aspect to stop. See, now I have a red over red. So everything is red. So I know that this is a true stop. Okay, and because it's on two heads instead of one, it's always an absolute stop. It's not a stop and proceed, not a permissive stop. Okay, so now that we can control the aspect of that signal, we can also go over here and I'll give you a slow approach on the dwarf head. Okay. And then I'll put him to stop. And then on the trailing edge, remember this one's upside down, okay? So I'm going to give you a medium clear signal. Okay, the top one would be red and the bottom one would be green. So the green would be in the second head. So that would be a medium speed. And I can give you a medium approach. Okay, so you see all this is built into JMRI. I didn't have to write a stitch of logic to get all the way up to the level of being able to display aspects and thinking in real engineer terms, real railroad terms, instead of hardware. Okay, so it's a great advantage especially for as non-programmers and stuff. It does all that for us. It's a great help. So now I want to get down a little bit into the logic of this. Okay, some of you guys may find this part a little boring. Some of you are going to enjoy it. Okay, I could call this up live in my Arduino, but for the sake of brevity, I'm going to pull it up here in my PDF. went too far, guys. Okay, this is the Arduino code. Now, I'm not a brain surgeon or or a scientist or anything. So my coding, I do coding, but I don't have time and knowledge to do some of this in-depth coding. So there's a guy out there that put this all in public domain for the Arduino. He wrote all this code for the CMRI logic that I use. Now, this is a communications code. And that basically means it's a way of sending the ones and zeros down a piece of wire. The best way you could relate to it is you speak English, somebody else speaks Spanish, but they're both communications codes. They're just done in a different language. And that's the way computers talk too. They talk different languages, okay? So in this case, CMRI comes out of JMRI and comes into my card. And the way it gets to my card, it has to be transported over those wires, okay? And so I need something that will catch all those ones and zeros coming into my card. And fortunately, somebody took care of that for me. That's this Auto 485. Remember I showed you that little 485 chip and said that's how it's communicating back. And I showed you the little adapter that plugs into the computer. So that captures all the ones and zeros for me and brings them into my little Arduino card and makes them available to me. Then within the Arduino, I have to define my hardware, because Arduinos, the inputs can also be outputs, the outputs can also be inputs. It's a very, very flexible card. So you have to tell it up front how you're going to use it. So you do that by defining things. So I define the main line as analog port 4, and I define diverging is digital port 4, and OS detection as digital port 3. Just now I can use the terms mainline, diverging, and OS detection in my code instead of having to remember these cryptic little numbers over here, okay? So it makes it very easy for me as the programmer. So then here on signal head 1, see these // that means that's a comment. That's all stored in there just for me. So when I come back to my code, I understand what I did, okay? So here I put a comment that I'm working on signal head 1, CH1, okay? Notice how I use terms that correlate back into the JMRI code, right? So I'm using a CH1, okay? This is my passing sighting, north passing sighting facing, okay? So I defined A green, A yellow, and A red, okay? And I call it A green, A yellow, and A red because that was the signal A as it relates back to my little PDF document. So you can see physically where that signal is located. And I drop down and I do more definition, signal head 2 for the A mast, okay? A bottom green, A bottom red. And I define those nice English terms for me. And then I move to the second signal mast, which is the B signal, okay? And I define B green, B yellow, and B red, and B bottom red. Remember, that was the 1/3 signal mast. And then I have my little dwarf, okay? And so I define the words C green and C red. So I don't have to remember all these numbers. I can use English terms now. Then I have my tortoise pins outputs, okay? Define T main and mainline and T diverging. Now I'm going to do something with all this stuff. I defined auto DE pin 2, DE pin as 2. Okay, and then I'm going to pass that constant into the auto 485 code. Now, I don't really care what's happening in there, but all I have to do is tell that piece of code what input pin I've dedicated to it to use, because it's going to use that pin to tell me I'm busy, I'm not busy, I'm transmitting, I'm receiving, okay? So that my code knows whether to accept it or wait for it. That's all we need to know about what's happening. All of that code's going to do is snatch those ones and zeros off that copper wire that's attached to it, okay? Then I'm going to define CMRI address. Remember in JMRI, when we defined our CMRI card, we started with address 0, okay? So I had to tell it the card I want to talk to, this one is going to be address is card 0. So that when JMRI broadcasts out there and says card 0, what are you doing? This card knows to answer, okay? Or when it sends it a command, it knows to obey it. So because it says card 1, I want you to do something, then address 0 will ignore it. That's all we're doing, is telling the code that somebody else wrote for us that its address is 0, and then it's going to be a CME card, okay? But all that is actually defined and defaulted for you. You really don't have to worry too much about it. Then in the setup code, setup is where you do something just once, okay? It's like setting the table for dinner. You put the plate out and you put the knife and the fork out, and then you're ready to use it. Well, before you can use this code, you set certain things up. So that's what we're doing in here. And it runs this part of the code only once. So it says bus begin. And that's telling the auto 485, hey, turn yourself on. Start listening to what's going on, okay? And then I set the pin mode mainline, okay? And I tell it it's going to be an input with a pull-up resistor on it. We won't get into all that, okay? But all I'm doing is saying, mainline, you're going to be an input, okay? Diverging, you're going to be an input. On station detection, you're going to be an input. And then I'm going to tell it all my LEDs that we defined, A green, A yellow, A red, those are all going to be outputs. Okay, so we're not going to take time to read all that. We know we need an output to drive every LED, right? So now we've configured the little nano chip, and it knows, oh, I've got 11 outputs and I've got 3 inputs. So it knows what it's looking for. Now we drop into the loop. And the loop simply means run through this code. When you get to the bottom, go back to the top, run back through the code again. So it just continuously loops through this piece of code, watching for whatever it's told to do, okay? So for most computers, the programs, if you don't put them in a loop like this, they run their code once and they stop. They said, oh, I did everything you told me to do. Okay, so you put it in a loop to make it continuously do it. So here's the key. This piece of code right here, CMRI process. That's the piece of code that somebody else wrote, that has sat down and studied and understands all the ones and zeros that are coming across to it from the JMRI. We don't need to know that. He says, here, just use it. All you have to do is tell me what you're getting and I'll tell you what it means, okay? So this is called, I can't even think of the name of it. It'll come. What you're doing is you're passing information to that piece of code, okay? And what you're gonna pass to it, CMRI set bit Okay, and set bit means you want to send a piece of information about an input to CMRI to send back up to JMRI. So what do we want to do? We want to set that bit 0 to digital read. That's a built-in command that Nano understands, and it wants to read the input that we've called mainline. Okay, and it's also going to read what the input that we call diverging. And it's also going to read the input that we call OS station. And if it's on or off, it's going to pass that code. Okay. And so now that comes back up to JMRI, and we can see that in our JMRI. Let's take a minute and do that so you can see it, how it works in real time. Okay, so I'm going to go back up here into my tools, to my tables, to my sensors. Okay, and you can see here that my Tortoise mainline is active and my Tortoise diverging is inactive. That means my Tortoise motor is set to mainline. See, my OS detection is inactive right now. Now, I'm going to put a jumper from my ground onto that, and you'll see it change state. See it go active? And now it goes inactive, active and inactive. So I'm feeding the information from my card into this piece of code, and that code is sending it back up to JMRI to use. Okay, and I've written just basic logic, very small amount of logic there to get that done, thanks to the good-heartedness of these other people that have written the code. Okay, now the outputs, right? I use a digital write. Okay, a digital write is the opposite of a digital read. I want to send something out from the card, so I'm going to control an output. Okay, so what I'm going to do is I'm going to go to CMRI. I'm going to talk to that piece of code, and I'm going to say, please give me the bit at address 0. Okay, please give me the bit at address 1. Please give me the bit at address 2. And I'm going to take those 3 pieces of information and I'm going to store them at A yellow, A green, A yellow, and A red. Okay, on outputs. And what that does is turn on and off my LEDs according to what's been sent to it from JMRI. So I'm not going to take time to do that, but you can see all I'm doing here is a bunch of digital writes to take the to take the output information that JMRI is sending to me and putting them to the right output to turn on and off the LEDs. And that's the end of the code, okay? Oh, and also there's the status for the main line coming in, okay? So let's take a look here at a turnout so we can control this Tortoise motor. We're gonna leave this sensor box open. Well, it goes away on me. We'll come back to it. Turnouts. First thing you're going to notice in this turnout is that it looks like I got a whole ton of them, and all I've got is one Tortoise motor. Okay, the truth is I only have one Tortoise motor, but signals are so interrelated with turnouts that JMRI defines them in the same data table. Okay, so you can see here I have CT1, CT3, 1, 2, 3, 4, 5. There's my 11 outputs, okay, for my signals. So they've been dumped into this table. See here, comments, in my comments, I put what signal head these are, okay? So you can ignore those. When I use an actual real turnout, I put a username in it. So down here you can see, just by going down the list real quick, you can see, oh, this is a real turnout, okay? And it's closed right now, right? And how do I define that turnout? Let me go over here. You use the add button, of course, right? And you define it right there. But since I have mine already defined, I'm going to use the edit button so you can see it all in one fell swoop, okay? So you give it a system name, CT12, username, North Passing Sighting, and you can put a comment in there if you like, okay? Now, a nice thing about JMRI, you're crawling around under that table and you get 2 wires reversed. Who wants to crawl back under that table? JMRI lets you invert those 2 wires if you need to, so that they operate backwards. That's a nice feature, okay? Now, the feedback. Hi, Clarence.
Hello.
Would you mute your microphone?
Okay.
Thank you.
I can figure out how.
Now on your feedback, I told it I'm going to use 2 sensors to monitor this turnout, okay? I could tell it 1 sensor, 2 sensors, or direct. What direct means is I'm going to operate it blind, okay? I have no feedback, okay? But since I do, I'm going to set it to 2 sensors. And then it says, okay, sensor 1, what's the first sensor you're going to use? Now remember, in our sensor table, we defined the OS detection, tortoise diverging, and tortoise mainline. So I selected tortoise diverging, okay? And for the second sensor, I selected tortoise mainline. So those 2 inputs are now assigned to this tortoise motor to give you status for this tortoise motor, okay? Turnout automation is turned off. Most of the time you're going to have that turned off. It's too deep to get into what we're doing today, okay? The other properties we can ignore. This is basically what you need to know about a turnout, how to hook up a turnout, okay? And I apply that, and my turnout is now listed and ready to go, okay? I can open that up a little bit. That'll help me, okay? And in the turnout table, you can see here, I've got that turnout highlighted in blue. So it tells me the feedback shows me that I'm closed right now in the closed position, okay? And it's doing that because it's using sensor 1, diverging, and sensor 2, mainline, to make that determination, okay? So now I'm going to see if I can get my camera back up, my second camera. There we go. Move it over so you can see my turnout flag. Now from within my logic, right now it's closed. So I want it in the thrown position. So it's thrown. And it's closed, okay? Now, I gotta hide that for a second. I'm trying to get my can I drop you out of there? Go away. Yeah. Drop out automation. Drop out the comment. There we go. Drop out the mode. All I did there, guys, was go through and filter my display. Okay. So now you can see my sensors. It says I'm closed. Well, I thought it was showing the sensor status, but it's not. It's just showing the names of the sensors. My fault there, guys. But if you look right there, you can see it changed. Now it shows it's in the thrown state. Whoops. And now the feedback is showing it in the closed state. Okay. So that's where those two inputs come from. So you can tell the status of a turnout. Now, why is all this important to us? Because the next lesson I want to teach about JMRI is how to build panels. Well, panels are dependent on your inputs and your outputs so that you get real world status coming back in from your railroad. Okay, so you needed to have a little history here on how to hook something up so that when I start explaining to you a panel, this is kind of a mystery that you remember, quasi-remember, quasi-understand. That's good enough, okay? But it should be enough to give you a confidence level to say, hey, I could actually hook things up to JMRI. I could actually have real live panels. This gives you the ability to put a panel, even a touch screen if you wanted to, at your yard with all the little track lines shown and everything, and little touch screens where you could throw the switches and status so you can see the status of what switches in what position, which would really help you. And of course, if you're a dispatcher, you need to know where a train is at. And that's what the on station is for. That on station is feedback that you would give to like a dispatcher, so that the dispatcher can see that that block is occupied, and you can lock that switch so nobody can throw it. Or you also know the status of the signals from that information. So there's a lot we can do here, but this is kind of the basic building block. And again, I just want to reiterate why I use CMRI. If you're using Digitrax and you want to stay strictly Digitrax, JMRI has every card that they make, so you can interface directly to it. DCE, same way. All the manufacturers are in there, okay? So now the name finally came back to me. I'm glad it did. I'm using CMRI, which was developed by Bruce Chubbs. I'm sure you guys have probably heard that name if you've been around the railroad modeling for a while. Bruce Chubbs developed the CMRI interface logic, and he's made it available through the National Model Railroad Association, so that anybody can use his communications platform. That's why I'm able to use it and not have to pay rights for it or anything. It's just free. All this is free. It's wonderful stuff. He also builds the CMRI cards pre-built. You don't have to be like me and build your own card. He's already got them manufactured. So you can just plug and play his whole system. Okay. Questions, guys? Got any questions? Pretty silent. There you
Jim,
go. Yeah, Clarence.
I'm actually Jim.
Okay.
But,
yeah, I see you, Jim.
yeah. Question I have for you is, just a basic electrical one.
Okay.
Where are you going to place these cards? How far from the turnouts, and how far from your whatever local net bus that you use?
Okay. The RS4 485 bus is good for basically 1 mile. Okay.
Okay.
So you don't have any problem with distance on the bus. Okay.
What gauge wire?
You could run your whole thing on 22 gauge wire. You
Okay.
could, safely, you could go up to 16. Okay. Most cards start having a problem when with the connectors if you go larger than 16 gauge wire, right? But again, it's not that sensitive. 485 has been around since the 1950s. It is in use in trillions and trillions of operations. It's just a hardened platform. It's, you're not going to have a problem with it. Okay.
Yeah, my second question is the green motherboard that you showed earlier.
Yes.
Is that a home built thing or something you purchased?
No, that's my prototype. I built that card. Okay.
Okay, and you use that on your layout?
I can. Right now, the layout I have doesn't need these. Okay. On my first layout, I actually bought the cards from Bruce Chubbs.
Okay.
So I purchased his cards.
Well, the reason I'm asking you, Jim, about the wiring is that I've seen Gilbert Freitags, which uses the full Chubb system. And the wiring is just amazing. To me, too much wiring. But how would it compare with what you're proposing?
Well, again, it all depends on how many things you're going to wire up, right? The wiring under my little 5x10 table was, 100 pages of diagrams to capture it. This card is designed. I designed it as a sighting card, okay, with a full load of signals. So that's how I described it here. So you could see I had 11 outputs to go to the 3 mast, and I had 3 inputs to give me status feedback from the Tortoise motor, and 1 for block detection to know if anything is on that switch. And then I had 2 additional outputs to control the Tortoise motor. So I had 11, and 3 is 14. I had 16 wires coming off this card.
Is that 1 card for 1 signal set and 1 turnout set, or
that would be 1 card to control 1 side of a sighting with full signal load. Okay, so if you wanted to do if it was a sighting that you could get in and out from both ends, then you would have another card at the other end of to control the other sighting.
But you need 1 485. I mean, can you change these things so it's only 1 485, or you have a USB port for each card?
No, one 485. You just daisy chain that communications to each card. Okay, so that it only uses 1 port on your computer, and you can have a couple hundred devices on 485. I've forgotten the exact number, but on a model railroad, you'd never exceed the number of nodes you could put on a 485 network.
Probably 255, something like that.
Yeah, that's a basic 8-bit number.
That's right.
Yeah. Did it clear things up for you, Jim?
Well, the question I guess brings up to me is that if you have 150 turnouts, you need 150 cards.
Well, not necessarily, Jim. What I've given you here is a dedicated purpose card, okay? You could use a general I/O card, which is all outputs or all inputs, or they make them with a mix of outputs and inputs. And so with the 16-bit output card, if you're using your Tortoise motors blind, you could control 8 Tortoise motors from that one card. Okay, so it's all in the design of your layout that would determine what type of card you would purchase.
Okay, that helps. Thanks.
Okay, yeah, this is, believe me, this is a very specific card that I built for a very specific reason. Okay, I do have, matter of fact, I've even got it working. I have a dedicated Tortoise Control card that I developed, okay, where you can use it for hardwiring routes, manually controlling your turnouts, controlling routes from a manual switch, controlling routes from a JMRI, from a screen on JMRI. I've got that prototyped and I've got it working. So see, I'm building the cards for me, for the fun. Okay, you can, I build them a whole lot cheaper than you can buy them. A JMRI card built is about $200. I mean, a CMRI card, okay, is about $200. Pardon me, guys. Sorry about that. So building these things, I'm down around $25 on each card, right? And you can see I've successfully interfaced them back to JMRI. I can control things, and I've cut my cost way down. And I'm putting the design, and I'm putting the part inventory list out to the public. So you know, even where to get the card built. So anybody that wants to build my little cards, it's going to be public domain. Okay, it's going to be free. Or if you want, I'll build them for you because I enjoy it. It's fun. Any more questions, guys?
Jim, this is Ray.
Hi, Ray.
Got a question for you on the, what type of are you using a track circuit detector, or can you wire one into the system?
Yes, that's what the OS detection input is for, right? For your block detector. Okay. Some people call it an occupancy zone. Okay. And that's what that's for. I've actually drawn up my little plan for one. I can build it for about $3. So I haven't built that card yet, but I've done the design work for it. Okay. I've also done the design work, and I have a crude working prototype for an output card to control servo motors, so that instead of using these expensive tortoises, if you wanted to use a servo motor, I can drive servo motors from a card just like this, and that little card can drive 48 servos, something like that. So you can get around your table and turn your switches pretty quick, pretty easy,
Okay.
pretty cheap. Okay, and the block detector, you know, I'll have that built in a month or so. It takes a while. I get the cards, I design them, and I ship the design off to China, you know, and get it built. And with the virus, you know, everything is slow now. So I'm waiting on a card to return. The
Jim,
card.
I've got
Yes, sir.
the cards that I use on my home layout you have several options and made by a different company.
Yeah.
When you turn on the layout after it's been shut down,
Yes.
they reset back to the original state. Can that be done with the Arduino cards?
With the Arduino card, you'd have to put you'd have to buy one that would accept this little storage chip where it could remember settings. But it's possible to do that with an Arduino, yes.
Okay. Very good presentation.
Thank you, sir.
Jim,
Yes.
I've actually done an Arduino card with that sort of thing. It's literally a 50-cent part, and 10 lines of code, and it'll remember states that you've had into it originally, so it doesn't reset.
Thanks for that input. Did you hear that, Jim, that he's already
Yeah.
done it? It's right.
Yeah.
And so it's proof and confirmed. Okay. Any more questions, guys? I believe me, I could have gone a lot deeper, but you know, time limits. Everybody gets kind of tired of watching it too. I understand that, but I wanted to give you a basic go through of how the hardware works, how to hook it up, right? How JMRI sees it. Really, it's not complicated to hook up once you do your first card, okay? It's that old saying, how to eat an elephant? One bite at a time, right? So you got to take that first little baby step. My mom also gave me some good advice once. I was a teenager and got my first job, and I went to my mom and I said, "Mom, I need a car. I need to be able to get back and forth to work." And she said, "Son, you got one in the backyard." Well, when my dad left my mom, he left a '56 Cadillac in the backyard with the engine disassembled. and I said, "Mom, I've never put an engine together by myself." And she says, "Well, son, you know, it's broken right now. So what have you got to lose?" And that always stuck with me, you know. So I went out and I put that engine back together, and I had to call a friend a little bit about the timing, but I put it together and it worked, right? And so it's just that doing it the first time, getting over that hurdle, you know, getting past the fear of the unknown. But this stuff can be done. It can be done cheap. It can be done reliably. The one thing that I caution everybody about, so when you start putting wire under the table, even simple, even just your power bus to your rails, draw it up, make a drawing. Because believe me, a year from now, when it breaks, you're not going to remember your color code. You're not going to remember, well, just because the wire went off to the left and one went off to the right, you're not going to remember where those wires were attached. Okay,
There's an
make some.
add-on.
Go
Yeah,
ahead.
there's an add-on to that. A personal experience. Don't get somebody help you that's colorblind.
You know, we do have some members of the club that are colorblind, and even just using these screens. When I wrote safety code for the oil field, we had to consider that when we made our drawings. We could use the colors red and green, which are the worst colors for a colorblind person, but we didn't rely on that color and only that color. We also had to change the shape of the object. We either had to put a slash or a dash over it, or move it to a 90-degree angle or something, so that if a colorblind person was using the screen, they had another visual indication of what was happening. So yeah, colorblind, that's an issue. It's a real world issue. All right, guys, I'm going to close it up here and wish you well. Hope the virus goes away. I would have liked to have given this in person. It's a lot more fun. This isn't bad. I enjoyed it, but being there is very enjoyable. So let's all stay safe. And let's get through this virus and get back together. Okay? I appreciate you logging in.
Thank you.
All right.
Thanks a lot, Jim. Talk to you later.
Bye,
Well
guys.
done.
Thank you.